Hello everyone. In the last class we have discussed about different concepts of climate changes. We have also tried to understand about the difference between weather and climate, and also different what you call definitions of climate change and how climate changes over time. And we have discussed about these three what you call episodes of the Earth's climate history, and we have not discussed in detail about the Holocene period. So today we'll try to understand about the Holocene period. So it can be actually divided into three different events. It it goes on like cool period, thermal, and little ice age. So we start with a cool period which roughly is about 11,500 to 10,000 years ago. New glaciers formed, trapping water as ice, and coastlines dropped, leading to massive migration of animals and early people to places like Australia and North America. This wasn't the first major period of migration or the last, but it was the big one. The next major event in the Holocene was the altithermal, the second one, a warming period, and also called the Holocene climate optimum, that lasted from roughly 9,000 to 5,000 years ago. The average global temperature increased by quite a bit during this time, and while still cooler than the today, and was characterized by a major shift in rainfall and vegetation, and it helped lead to the rise of many ancient civilization like Egyptian civilization, Maya civilization, Chinese, Indus Valley civilization, Mesopotamia civilization, etc. So you are quite what you call accustomed with all these civilizations. All these great civilizations actually come up within this time period. Now the last what you call known and very renowned stage we call little IHs. It's in another rapid cooling of between around 1450 to 1850 CE. This really hit the northern hemisphere most dramatically, and it is actually worth noting that paintings from the northern European Renaissance saw a huge focus on snow and ice during this time. As you can see this painting, the little ice age changed the way that people lived, but after 1850 the earth steadily started warming up. So these are the what I call other divisions of Holocene period. So we have also introduced in the last class regarding the impact of climate changes in the last century. So today we'll begin with some of the major impact of what you call climate change in the last century. The first one is sea level rise. So sea level worldwide is rising from the graph. We see the measurement of how much sea level has risen. It is clear that it has risen about 20 centimeters since the late 19th century, which has accelerated in the last decades, as can be seen from the graph. Okay, from the graph, the called x-axis, uh, it is the year, and in y-axis the sea level rise. It is in millimeter. So if you convert it into centimeters, so if you can estimate the what you call the amount of sea level rises within last what you call few decades, it is around 20 centimeter. So the main causes of the sea level rise are warmer ocean, which take more volume and water. And second one is land ice melting, that is the mountain glaciers, but also the big ice sheets on Greenland and Antarctica. So these are two main reasons of sea what you call level rise. When what you call water or anything is warm up, it swells up or it gains its volume. So similarly in case of water, when the earth itself is warming, the oceans are warming, so it swells up. And secondly, even due to the melting of our great ice sheets like ice glaciers of Antarctica or Greenland, that is why also sea level is rising. Okay. So from the picture you can see the change in melting of what you call ice sheets in Greenland over time. So the IPCC AR4 reported that around 0.41 to point plus minus zero point 0.4 millimeter per year as the rate of sea level rise from the ice sheets for the period of 1993 to 2003. Even while a more recent estimate by Charles et al. In 2011 gives around 1.3 millimeter per year for the period 2004 and 8. And how much each of these contributes depends on the exact time period you are looking at. So the evidences from the study says that it was about half of the rise caused by the expanding of water due to it warming up, and the other half is due to ice melt. The contribution from ice melt, in particularly the two big ices in the Greenland and Antarctica, has greatly increased and has become the dominant factor in causing sea level rise. So climate scientists have studied about accumulated in salt marshes along the coast. They found that sea level was fairly stable during those last 2000 years. Okay, from this graph you can estimate this one. There was a little bit of slow rise during the medieval warm period, but the modern rise has only started in late 20th century, the last portion of the graph, when global warming also has started. Now, they also try to put the past data together and also look at the future of sea level. It was evident from the diagram from the latest IPCC report, which shows that the sea level rise since the year 1700 AD and the started of modern rise in the late 19th century, and it also looks at the two scenario for the future. Okay, so the first scenario, if the global warming never stops, then it will rise up to this level. But if we can control the rise of temperature of the earth or the climate system of the earth, then we can actually what will control the sea level rise up to this is the what you call projected what you call value up to 2000 what you call 21,000. So this is one of the major impact of climate change, that is called sea level rise. The other impact is the heat extremes. Over the last decades, we have observed a very significant increase in heat extremes, 10 times more areas of the planet affected by heat extremes in the last 40 years. One of the consequences of global warming is that average warming will increase length, intensity, and frequency of heat waves. Numerous studies have confirmed its impact. Uh, like yeah, from this is one of the what you call impact of climate change. See, the heat extreme has been increasing in recent years, and its intensity has also been increased. This is one of the major impact. And so from this graph also you can estimate that the number of casualties due to this heat extreme has also been what you call increased in recent years from the graph. So in 2003 heat waves, in this is the data from France, number of deaths in 2003 due to heat extremes. So numerous studies have confirmed its impact, like increase in human mortality, agriculture, economic development and growth, particularly in poorest region. So one of the major concern as observed by the scientists in increasing aridity in the sub-Sahara Africa due to the increase in temperature extremes combined with projected change in rainfall. This is very important impact of the increasing intensity of heat extremes. There is increasing arid areas in sub-Saharan Africa. Aridity, if it is increases, will affect and decrease livestock production and crop production throughout the region, and it will create risk to food security and people's livelihoods. With ever increasing droughts in the region and these factors together, the people will not be able to feed themselves and affect the sustainability of society in the region. The consequence could felt regionally with population migrations leading to regional security issues and other related problems. The third great impact of climate change can be seen in ocean acidification. It's the other. Okay. So when scientists try to look at changes in global climate, what they look at? What are the approaches to look at climate change? They look at a number of different measures uh, to call to see if indeed they are getting a consistent picture of change or not. First, as we have mentioned earlier, they look at thermal or temperature indicators. In previous video lecture, we have discussed about the temperature indicators also. So these are now there are a number of different ways in which we measure temperature of the earth or this or the global we'll call earth system. Okay. So the most common is the land surface air temperature over the globe. You can see a general rise in temperature, especially over the last several decades from the graph itself. See, the land surface temperature have been increased. These are different studies taken by different agencies. So almost all what you call trends are showing the same trends or what you call similar trend. The different color lines represent different analysis teams analyzing the data. So it is quite obvious that the land surface temperature is changing. So there are traditional method to measure the land surface temperature, or nowadays we can also assess the land surface temperature using satellite images from thermal images of the satellites like this. The other approach to measure temperature content is ocean heat content. The ocean heat content is one of the measures to look at the changing temperature of the global climate system. It is very important indicator of changes. Approximately 93% of additional heat absorbed by the earth system resulting from an increasing in greenhouse gases concentration since 1955 is stored in the ocean. So this is very what you call important thing, that 93% of additional heat absorbed by the earth system due to global warming is stored in ocean itself. That is why oceans are swelling up. And only 3% has gone to warming the land surface temperature, and other 3% of heat that is gone into melting snow in the northern hemisphere. Only 1% has gone into warming the atmosphere. So from the graph itself you can see this is also another study how this ocean heat content is alarmingly it is increasing in such a high pace in the last centuries. Okay. The another approaches to look at this climate system is the climate model. So we know that burning fossil fuels could lead to warming the earth as more carbon dioxide we are releasing, so more heat will be trapped in the earth system. So carbon dioxide and several other greenhouse gases live in atmosphere for very long time. One simple way to think about this is an analogy often used to as a bathtub. Imagine filling a bathtub with very clogged and slow drain pipe. The bathtub fills up faster and faster as the drain refuses to let the water out. So similarly in case of atmosphere also, our inlet we are putting more and more carbon dioxide, but the earth system is, or the earth system is not absorbing, the plants are not absorbing carbon dioxide at the same rate. That is why the amount of carbon dioxide in the atmosphere is, or other gases is, increasing day by day. With increasing development activities, we are adding more and more carbon dioxide in the atmosphere, generating more and more heat. So what will be the future of the earth? Scientists use a technique referred to as emission scenario that refers to a pretty simple idea to create a consistent story about what the future might look like, a kind of future projection. How much will emissions of carbon dioxide increase in future? So scientists build different climate models, okay, to estimate the future, to project the future carbon dioxide emission, how much heat it will be, considering different factors, okay, ranging from biochemistry of greenhouse gases, ocean atmospheric interactions, earth's heat balance, man-made pollution, ocean circulation. They had everything here to estimate the future prospect of this climate change variables. So all these models come down to just a few variables. All this climate model actually point out to the main four factors actually, and which are built upon assumptions about basically four things. The population growth, so more people, more energy use, more carbon dioxide will be released. Then energy choice, what type of energy the population will choose to use by we have different renewable source or non-renewable sources of energy. There's a choice of people, energy choices. The third factor is economic growth. The faster economy grows, the more energy they will need and the more fossil fuels they are likely to consume. And the last factor which actually depend is the technological innovations, and some people think that technological innovations will save us. So these are the four main factors which actually uh, define what our future would look like or what our future would be. So scientists currently estimates that increase in temperature, which is about 2 degrees centigrade at global average. Okay. So climate model is one of the approaches to look at the global climate and how it will be in our future. So the last one, but indeed not the least, there are more other what you call approaches to look at climate, but these are main important what you call approaches to look at climate, global climate system. So to understand climate change and to make useful prediction, we have to understand many aspects of our what you call uh, planet Earth. Climate change involves an interaction between the different components of Earth's system: the atmosphere, the ocean, the land, the ice, and the biosphere, including vegetations and carbon coming from animals. This complexity makes climate observation challenging. Okay, but thanks to the satellite era, which has changed the process of weather forecasting and climate. So you are well aware of this, is not it? People now can see the planet in a way that cannot from the ground. Even in your mobile phone, from the Google image, you can change to satellite mode and you can see everything in the ground, which we cannot see actually earlier. So we can see very clearly the weather pattern also. The satellite era has also changed chemical composition forecasting because it was not possible for the ground to obtain a global view of the state of atmosphere. What are the chemical components in the atmosphere? Now with the help of satellite we can have it. It allows to connect together our sporadic and sparse data points in a way that model do not do as well. So this is a SAR data, we call it SAR data, and the black area is a real time data of what you call flooded water, or this the water bodies. So from SAR data we can what you call look at the water bodies, and if there is any area flooded during certain time we can estimate from it. Although the models gives us a picture, they are not usually real data, but these are satellite actually give you the real time data. Whereas Earth's observation give us real temperature, salinity these days, ocean color for things like phytoplanktons and sediments in coastal zones, as well as sea level, and these are fundamental in trying to understand the long-term changes over the past decades and future decades that are occurred in our oceans. So these are the different approaches, but not the least. There are lot more approaches are there to understand climate, what you call global climate system, but these are the four main approaches. Okay, thank you very much. Have a nice day.